Okay, question 1. Use the balanced chemical equation N2 plus 3H2 yields 2 NH3. If there are 12 moles of N2, how many moles of NH3 will be produced? Well, first of all, what you need to do is identify what's been given to you and also what you're looking for. So 12 moles of N2 is the information you've been given, and then how many moles of NH3 will be produced. So I'm going to write down first what I've been given, which is 12 moles of N2. Because I'm only going from moles to moles, it's very simple. All I have to do is set up a mole ratio. So if I look here, I have 1 mole of N2. That's going to go on the bottom there because I want to get rid of it. And then I have 2 moles of NH3 because there's a coefficient of 2 in front of that compound. So I'm going to say 2 moles of NH3. Okay, now I can cancel my units. So the moles of N2 cancel. The only units that I'm left with is moles of NH3, which is exactly what the problem asked me to find. How many moles of NH3 will be produced? So I multiply the top numbers. So 12 times 2 would be 24. Divide that by the bottom number, which is 1. Okay, which is easy. So that gives me 24 moles of N2 as my final answer. Okay, that's just kind of showing you a quick description of how to solve that problem. Really, you can just plug this into the calculator. When we get to more complex problems, you'll get to see those. Okay, so our next problem asks us to use a different balanced chemical equation. It says how many liters of oxygen are required to react completely with 3.6 liters of hydrogen and H2O. I've already underlined the things that we're given and what we're looking for. So we're given 3.6 liters of hydrogen and we're looking for how many liters of oxygen. Okay, so first we're going to write down what has been given to us, which was 3.6 liters of hydrogen. Hydrogen is H2 in this chemical equation. Okay. First of all, I want to go from liters to moles. So I know that 22.4 liters of hydrogen is what 1 mole would occupy. Okay. All right, now that liters cancel, I'm left with moles. I now want to set up a mole ratio now that I'm in moles. So I know that hydrogen has 2 moles. Okay, I'm putting hydrogen on the bottom because I want to get rid of it because I want to find oxygen. And I know I have only 1 mole of oxygen because there's just a coefficient of 1. Okay, so moles of H2 would cancel. Moles of H2 would cancel. I'm left with moles of O2, but I want liters. So now I'm just going to use this same conversion that I had from before, but flip it. So now that 22.4 liters of O2 over 1 mole of O2. Okay, so moles of O2 cancel. I'm left with liters of O2, which is exactly what the problem was asking me. So if I take a calculator, okay, I can plug in everything exactly like I see it. So I'm going to take 3.6, I'm going to start a set of parentheses, times 1, times 1, times 22.4, okay. Really, I don't have to put the ones there because anything times 1 is itself. So I don't always really have to type those, but I'm just typing every number that I see from the top, and it's going to be divided by all the numbers from the bottom. So 22.4 times 2 times 1. Okay, close that parentheses. So by doing that, I've taken everything from the top is going to be multiplied by each other, and then it's going to be divided by all the numbers from the bottom to multiplied by each other to give me my answer of 1.8, which is answer C, 1.8 liters. Okay, next problem. For problems 3 through 6, we will be using this equation here. So number 3, how many moles of H2SO4 are needed to completely react with 15 moles of Al? Well, so first of all, what we need again is find out what we've been given. So it gives us 15 moles of Al, and then ask how many moles of H2SO4 are going to be needed. So moles of H2SO4. So in this problem, start with what we've been given. So 15 moles of Al. Okay. So 15 moles of Al, and then it asks, because we're just going moles to moles, all we have to do is set up a mole ratio. So if I look at the problem, I have 2 moles of Al because of the coefficient here. So 2 moles of Al, and then H2SO4, I have 3 of those. Okay, that would cancel moles, and leave me with moles of H2SO4, which is what the problem's asking me to find. So I'm going to take the top 15 times 3 divided by 2. Okay, so again, I can just put that into the calculator. So 15 times 3 divided by everything that's on the bottom, which gives me 22.5 moles, which is answer choice C. Okay, number 4, starting with 15 moles of Al, determine the theoretical yield of H2. Okay, well, we've already saved ourselves a little bit of work because we had already started with 15 moles of Al, or found out how many moles that was in the problem above. So again, we took our 15 moles of Al, set it up as a mole ratio, which gave us 22.5. Okay, if we just took that same ratio, okay, same ratio that is in moles now. So if I cancel my units, moles of Al, it leaves me with moles of H2. Well, in order to convert moles to grams, I'm going to have to find the molar mass of H2. Okay, and so the molar mass of H2 is 2.018 grams, and I know that that is equal to 1 mole of H2. Okay, so when I plug this into a calculator, 15 times 3 times 2.018, okay, and then divide that by everything that's on the bottom, so 2 times 1, so divide all of that by 2, it gives me 45.405 grams, which rounds to answer choice A here, 45.5 grams. Okay, question 5. If the actual yield of H2 is 43.2 grams, use a theoretical yield calculation from question 4 to solve for the percent yield. Okay, well, from problem 4, we found that the theoretical yield was 45.5 grams. So in order to find percent yield, okay, percent yield is equal to the actual. So it gives me the actual right here of 43.2 divided by the theoretical yield, which we said was 45.5 from the problem above. And then we're going to multiply that by 100 to give us a percentage. So if I just put that in the calculator, 43.2 divided by 5.5, okay. So that's in a decimal. I multiply by 100 to make it into a percentage. So 94.94%. Okay, 94.94. Obviously, if I look at the answer choices, 94.9, I'm just rounding that number to give me answer choice A. Okay, so number 6 is a little bit of a long problem, just because it asks us to start with 13 moles of AL this time. So essentially we're doing the same process that we did through 4 and 5. We're just starting with 13 moles of AL rather than 15 moles of AL. So we do the same process here. Take what I've been given. So it tells me to start with 13 moles of AL. Okay. And I want to calculate the percent of H2. Okay. So my percent yield's got to be in grams. So I'm going to take my moles and I'm going to convert them to grams. So because I'm in moles, I can set up a mole ratio between aluminum and H2. So aluminum is going to be on the bottom. So if I look at my, again, original equation, I have 2 moles of AL. So 2 moles AL, and then I'm comparing it to H2. So if I look back, I have 3 moles of H2. Okay, so that cancels moles of aluminum, leaves me with all moles of H2. But like I said, in order to do percent yield, you're going to have to be in grams. So I'm going to need to find the molar mass of H2, which I already found in the other problem before this, which was just 2.018 grams. Okay, and we know that 1 mole is equal to the molar mass of a substance, so H2. So moles of H2 cancel, leaves me with grams of H2, which is what I'm looking for in order to find percent yield. So if I calculate that, that gives me 39.351 grams. Okay, so what we just found is the theoretical yield. Okay, I want to know percent yield. So I'm going to take the actual, which they gave me was 35. So 35, the actual, over theoretical, which is 39.351, which is what I should have gotten. Then I multiply that by 100 to convert to a percentage. Okay, so I trust that you can plug that into a calculator. When you type that in, it should give you 89.1%, okay, which is answer choice B.